So this first one's pretty easy, right? There's a one-to-one correspondence between the output and the input, so that's clearly a map operation. Now this next one is also a one-to-one operation. One value gets written in the output array corresponding to every value that gets read from the input array. And you can see that we're writing into an array which is represented in I major order here in the output and in J major order in the input. So this is a transpose operation. Now this next code, as I said, I put a guard around, right? Only the odd numbered threads are going to execute this. So that rules out a map, it's not one-to-one. And that also rules out a transpose operation, which is also one-to-one. And you couldn't really call it a stencil operation either, because a stencil operation should generate a result for every element in the output array. And this doesn't do that. Now if you look at the first one, the thread is taking the input at a given location and multiplying it by pi and placing that into a couple of different places in the output array. In fact, it's incrementing a couple of different places in the output array. So this would be a scatter operation. The thread is computing for itself where it needs to write its result. And this final line would be a gather. You can see that every thread is writing a single location in the output array, and it's reading from multiple places in the input array, locations that it computes. So this would be a gather. And again, this looks very much like a stencil operation since it's reading from a local neighborhood and doing some averaging and writing the result. But I wouldn't call it a stencil because it's not writing into every location because of this guard here. So that's why I refer to this as a gather rather than a stencil.